Hi linear algebra students. In this video, I will explain a formula that I threw at you in class without much explanation. It's the formula that defines the angle between two vectors. And it doesn't seem to be very important because in R2 and in R3, we can easily visualize an angle. So you've never needed that formula before. However, where it becomes useful is whenever the vectors are in R4 or R5 or in general in Rn. Okay, so you define the angle between two vectors u and v by saying that the cosine of the angle, so the cosine of theta, must be the same as u dot v divided by the norm of u and the norm of v. Okay, so now let's explain how we construct this definition. Okay, what we need to do is we need to look at the standard law of cosine that is satisfied by triangles. Okay, so if you have a triangle and this triangle could be oblique, something like this, let's say, okay? Then if you have A, B, and C, like this, and if you define like the angle theta to be, let's say this is the angle of theta, and actually I will change my size a little bit to make the explanation easier. This will be B, and this will be C, let's say. Then the law of cosines tell you that c squared is equal to a squared plus b squared minus 2ab cosine theta. Okay? So to define the angle like this, what we will do is we will take two vectors. One vector will be u. Okay, so actually let's color code them at this point. So I will take, let's say, a purple vector. This will be u. And instead of b, I will have like the vector v. And then the vector in between, so this vector right here, so will be u minus v. Okay, I just need to be careful here. So here we have like v plus u minus, yeah, this is u minus v. Perfect. Okay, so we take u, we subtract v, we get that. Okay, so we take this triangle, and the way we want to define the angle between the vectors u and v, so it's going to be like this angle over here. Let's color code it in green. Is that we want this law of cosines to be satisfied for these three vectors. So basically, what do we want? We want the norm of u minus v, okay, squared. We want this to be equal to, so equals to the norm of u squared plus the norm of v squared. So norm of u squared plus the norm of v squared minus 2 norm of u, norm of v, norm of u and norm of v, times the cosine of the angle. Okay, so that's how we want to define this. Okay, now we can okay, so we will be able to easily solve for this, but first let's write what is the norm of u and v on the other hand. Okay, so let's put it this way. On the other hand, so we can say that the norm of so the norm of u plus v, the norm of u minus v, okay, squared. This is the same thing as the dot product of u minus v with itself. Okay, and from there we use the properties of the dot product. So in other words, we use the fact, for example, that we can expand. Right? Actually, here I'm going to go rather slowly, but what I'm using in reality is left distributivity. So in other words, like u minus v times u. Then, just to make sure, yes, perfect. minus u minus v times v. And then for each member, I use right distributivity. So in other words, what's going to happen is I have u dot u minus v dot u minus u dot v, okay? And then minus of a minus will give you plus v dot v, okay? Which means that, and now we also use the fact that the dot product is commutative in order to write that this is going to be u squared minus 2 times u dot v plus the norm of v squared, okay? So we established with, so basically all of these equalities, all of these steps are done by using properties of dot products. Properties of dot product. So now that I have this, let's erase. Yeah, let's actually erase this. So in other words, by comparison, I can say that this thing, okay, so I will just rewrite it, u squared minus 2u dot v plus v squared, okay, is equal to this bright colored side, right? So again, we have u squared plus v squared, okay, minus 2 uv cosine theta. Okay, and now what is going to happen? Well, as you can see, oops, I forgot a square here. Well, as you can see, the v square will cancel with the v square. The u square will also cancel. Okay, so we will be left with this is equal to this. Let's actually write it down. We have negative 2u dot v, okay, is equal to negative 2, then uv cosine theta. Oops, sorry about that. And of course, as a result, well, we get our formula for the angle. Okay, so we get here that cosine of theta is going to be like the dot product. So the black dot product that we have over there, u dot v, okay, divided by the coefficient right here. As you can see, the negative 2's cancel, so we're not worried about them. Divided by u, the norm of u, and the norm of v. All right, so so this is it. This is how the angle between two vectors are defined. So what you should remember is basically it is, first of all, it is not a theorem. It is a definition, right? That's how we define the angle between two vectors. And we define it in a way to satisfy the laws of cosines on vectors. Okay? So hopefully this was helpful. See you either in class or in the next video.